This is section 3.7 of Honors Algebra 2, linear inequalities in two variables. So we've been dealing so far this chapter with linear equations in two variables, like the one that I've given you here, y equals 1/2 x plus 1. That's a linear equation in two variables. That's one happens to be in slope-intercept form. Well, linear inequality in two variables could look something like y is greater than 1/2 x plus 1. So instead of the y being equal to 1/2 x plus 1, y might be greater than it, or it might be less than, or it might be greater than or equal to, or it might be less than or equal to. It also could be a sentence of this form: 2x minus 3y is less than 12, which is still linear. That one just happens to be in standard form. Or it could be y is greater than or equal to x, which is actually slope-intercept form with a slope of 1 and a y-intercept of 0. So linear inequalities in two variables could take any of these forms. A solution of an inequality in two variables is an ordered pair, x comma y, that satisfies the inequality. That when I plug in that number for x and that number for y, the inequality is true. There are infinitely many solutions to an inequality in two variables, not just one, and our solutions are not limited to a line anymore. They're a whole region of the graph. So, Mr. Shaver, how do I graph a linear inequality in two variables? Excellent question, Bobby. How to graph a linear inequality in two variables? You follow these two simple steps. First, you graph the associated equation, meaning the equation that you would get if, instead of an inequality, you had an equal sign. But when you're graphing that line, if you have a less than or greater than symbol, use only a dotted line to indicate that you will not accept points on that line. If, however, you have a less than or equal to or greater than or equal to symbol, use a solid line because you will accept points on that line. Second step, after you've graphed that line, either as a dotted line or as a solid line, you need to shade the side of the line that contains the solutions of the inequality. That side that you shade is called a half plane. It's half of the coordinate plane. You're dividing the coordinate plane in half by the line that you're drawing. You're shading 1/2 of it, either below it or above it. How do you determine which half plane to shade, whether you're going to shade above or below? Well, plug in the point 0, 0, the origin, into the inequality. Plug in 0 for x and 0 for y. If 0, 0 is a solution, if the inequality is true when you plug in 0, 0, shade the half plane that the origin 0, 0 lies in, because that point needs to be in the set of solutions. If 0, 0 is not a solution, if the inequality is not true when you plug in 0, 0, shade the half plane that the origin 0, 0 does not lie in. Why do we pick 0, 0? Because it's convenient, because zeros make it easy to figure out the inequality. We could use any point, really, and the same thing would be true. If that point is a solution, we shade the side that that point is on. If it's not, we shade the other side. But 0, 0 is the easiest point to plug in. So now let's do some examples. Example number 1. 3x plus 2y plus 4 is greater than or equal to 0. Is that linear? Sure. It just happens to be in somewhat standard form. We just need to move the 4 to the other side. So let's do that first. 3x plus 2y is greater than or equal to negative 4. Okay? I think it's easiest to graph it in slope-intercept form, so I'm going to put it in slope-intercept form. Y is greater than or equal to negative 3 over 2 x minus 2. If I move the 3x to the other side and divide everything by 2. So what I'm going to do first is graph the associated equation. I'm going to graph it as if it were y equals negative 3 halves x minus 2. Do I want a dotted line or a solid line? A solid line. Very good, because it's greater than or equal to, not just greater than. So I will accept points on the line. So to graph this, I start with the y-intercept of negative 2. I'm going to put a point there. I'm going to use my slope to find another point, so I'll go down 3 and over 2 to the right. And that point is the point 2, negative 5. And my y-intercept is the point 0, negative 2. I'm going to draw the line, and I know it's a solid line, so I can Draw it as such. So that's step number 1. Step number 2 is I need to figure out which side of the plane to shade, and then shade it. So I plug in 0, 0, which you'll notice is above the line. So I'm going to plug in 0, 0 and see if it works. Is 0 greater than or equal to negative 3 over 2 times 0 minus 2? Well, negative 3 over 2 times 0, 0 minus 2 is negative 2. Is 0 greater than or equal to negative 2? Indeed it is. So I will shade the side of the line that 0, 0 is on. You can just shade it with your pencil, or if you have a highlighter, that would be awesome. But your pencil's good too. And so that represents all of the solutions to that inequality. All of the solutions either lie on that line, since it's greater than or equal to, or in the shaded region, which does not end on the graph there. It keeps going. But we understand that. Number 2, 3x minus 2y is greater than 6. So, again, I like to see it in slope-intercept form. If the, or let's graph the x and y intercepts. The x-intercept will have when y is 0, so that would make x equal to 2. So the point 2, 0. The y-intercept will happen when x is 0, which would make y equal to negative 3. Right there. 0, negative 3. I draw the line. Do I want a solid line or a dotted line? Dotted line! So I draw myself a neat little dotted line, dash line. Plug in the point 0, 0. Well, 3 times 0 is 0, minus 2 times 0 is 0, 0 minus 0 is 0. Is 0 greater than 6? No, it's not. So I shade the side that 0, 0 is not on. So I'm going to shade, in this case, below my line, down here. So all the solutions lie in this shaded pink region. They do not lie on the line, because it's just greater than, not greater than or equal to. Example number 3. X minus 3 is less than 0. Can I graph that if it doesn't have a y in it? Sure, I can. Let's understand what this is doing. It means that x is less than positive 3. The associated equation would be x is equal to positive 3. That is what kind of a line? A vertical line, where every point has an x-coordinate of 3. So for example, the point 3, 0, or say the point 3, 3, and we draw ourselves that vertical line, except we make sure that we don't draw a solid line. We draw a dotted line, because it is just less than. Okay, now which side of the graph do I shade? Well, I plug in 0, 0. That means I'm just plugging in 0 for x, because there's no y. Is 0 less than 3? Sure it is. So I'm going to shade to the left of my line. And when you have an inequality like this, it's actually really easy to understand where you're shading, because it means x is less than 3. Well, you are in fact shading the values where x is smaller than 3. And that will always work out like that. Same thing if I had a horizontal line like y is greater than 4, I would shade above my line of y equals 4. One last example. Graph the system of linear inequalities. Now I've got 2, and I want to only graph the solutions that lie, that solve the system, so that work for both inequalities. Tricky, tricky. So first, x plus y is less than or equal to 6. That means that both my x and y intercepts are 6. So I've got a point at 6, 0 and a point at 0, 6. That is a solid line. So I draw a solid line through there. Then I've got 2y is greater than x. And that one is the same as y is greater than 1/2 x. So that's a line through the origin, a y-intercept of 0, with a slope of 1/2. So we've got the origin, 0, 0. Slope of 1/2 means I go up 1 over 2, and I'm at the point of 2, 1. That one is a solid line, a dotted line. Draw my dotted line. Now I need to figure out where to shade. Well, for the first line, which half plane would I have shaded if that was my only graph? I plug in 0, 0. Is 0 less than or equal to 6? Yes, it is. So for the first line, I would shade below it. And I'll go ahead and do this in yellow. Notice this is not my final answer. For the second line, if I try plugging in 0, 0, I get that 0 is greater than 0, and that's just absurd. The problem with that is my line goes through 0, 0. So I need to pick a different point. I could pick the point 0, 2, which is above the line. So let's try the point 0, 2. If I plug in 0 for x and 2 for y, I'll get 2 is greater than 0, which is true. So where I want to shade there is above my dotted line, so this region. So where are my solutions to this system? Well, my solutions to the system are where this turned out to be green, where the yellow and the blue made the green. So my solutions, it turns out, are just in that one region that's green there. So, and they include that line, but not that dotted line. So just this region here. So make it clear where your solutions are. Maybe draw an arrow and say, those are my solutions. Here are your immediate practice problems. Graph each inequality. Number 1, 3x minus 2y is less than or equal to 8. Number 2, y is less than 1/2 x minus 4. Graph each one of them. Shade the appropriate region. Write down each equation, or each inequality, I mean. And that is the end of section 3.7.